to everyone and welcome to this Pipeline Industries Guild webinar. And for those of you who do not know me, I'm Norman Howell and I'm the CEO of the Guild. Now we have got a slight technical hitch today. With our speaker from Cadent, Kate Grant, who's just having some trouble connecting. So we're going to start as per our program with our presentation from Joseph Gallagher Group, and then we'll have to see after that if Kate's managed to log in. If she hasn't, then I'll arrange for her to present at a point in the future. So today's webinar is the third in our series of introducing the sponsors from this year's Guild conference, and we, as I said, we have got two presentations hopefully today. The first is from the Joseph Gallagher Group, and then the second's from Cadent Gas. Our first presentation will be given by Cameron Davis of the Joseph Gallagher Group, who'll be providing us with an overview of the construction of a complex shaft and microtunneling section of a new strategic gas pipeline, which forms part of Centrica's Tolmount Gas Pipeline project located in East Yorkshire. And then hopefully Kate Grant of Cadent Gas will be providing us with an insight into the engineering challenge of moving our gas networks towards a net zero future. Before we start, I'd just like to advise you that there will be opportunities to ask questions after each presentation is completed. So to help us manage the Q&A session, can I ask you to post your questions within the chat function, and then I'll manage those questions, as I say, after each presentation. So without further ado, I'd like to introduce our first speaker, who is Cameron Davis of the Joseph Gallagher Group. Cameron is an engineering technician who's been a member of the Institute of Civil Engineers for 4 years, and he's also a member of the British Tunnelling Society Young Members Subcommittee. And as I mentioned earlier, Cameron's presentation will cover the Joseph Gallagher Group's involvement in the construction of a drive shaft and 146 metre long microtunnel that was part of the Tolmount Gas Pipeline, which forms part of Centrica's Strategic Network for the northeast and east of England. And this complex assignment was successfully constructed in 3 distinct phases of work over a 12-month period within the COVID pandemic, and was completed in January of this year. So I'd now like to hand over to Cameron to provide us with his presentation. Thank you.
Thanks, Norman. Hello, everybody. Thanks for taking the time out to join this webinar today. As discussed there, we're going to talk about the Tolmount Gas Pipeline project up in Easington in Hull, and I hope you enjoy. So just to run through the slides. So a background of the project. So it was be formed, as we've said there, as the Tolmount Gas Pipeline within the Centrica gas terminal on the eastern edge of Hull. JGL's package worked within a design and build contract with Saipem being our client, Premier Oil being their client above for the main infrastructure. Our works were to install a segmental 5.5 metre diameter shaft down to 21 metres, and then obviously, like Norman said, there were 145 metres of pipe jacking at 1200 internal diameter. The works took place over 3 distinct phases. So prior to Christmas 2019, JGL undertook and sank the 22 metre deep shaft, completed and back grouted on departure. In March 2020, obviously we know during the COVID, sort of the start of the pandemic, we chose to continue on and do our 1200 pipe jack into the shaft, into the cofferdam out towards the North Sea, which was installed by others. And lastly, in January 2021, just gone, we finished the final completion. There was a pulled pipeline in from the North Sea that we grouted successfully. Some general locations. So you can see on the left-hand side photo that was where the cofferdam was sitting. It's been removed now from the sea, but you can see what a lovely part of Hull we was in, with a lovely view of the North Sea. On the right-hand side there, you can sort of see a overall picture of where Easington sits within the United Kingdom. Like I said, it's right on that far edge of Hull. So project location and constraints. Like I said, the project was in Easington, which is 45 minutes east of Hull, towards the North Sea. So it's really only a single track route in and out of Centrica there. So it was difficult logistical was a problem there. It was working actually within the Centrica gas terminal. So what people might not know about is it's a tier 1 coma site. So it's very sort of looked after and very disciplined on the site. So there was all lots of inductions and obviously the restriction of phones and obviously anything that causes spark. So it was a very sort of new site compared to what we normally do. So it was a good challenge. There was a large permit system in place with Centrica. Obviously, there was a lot of pre-work for documentation and approval for the works. This was all completed by JGL and submitted to Saipem and then submitted onto Centrica. So there was a clear sort of process all throughout. Plant and equipment, so electrical plant on site and anything we use within the shaft has had to be intrinsically safe. Adaptations to plant and kit and sort of excavators had the Chilwell valve and the spark arrestor. Again, this was an addition that our company at NRC Cranes was able to retrofit onto the plant that was sent up for the work. Like I said, there's a single track route from Hull to the work site. Sort of deliveries you could always guaranteed to get stuck behind a bus or something a bit slower on the single track route. So it did make it a bit of a pain sometimes. And like we said there, obviously the spark arresters and the additional control measures for the coma tier 1 site was also placed onto our pieces of equipment. So the tunneling GI and the design, so all the GI and the designs was all done by JGL's in-house design team. So we have our own design team there in Leeds. The deliverables were the following 4. So the shaft design, including the collar flotation, including the collar and the flotation, the shaft sheave base block for the winching of the pipeline. You'll see in one of the photos there, the pipeline that was original design was to be winched from the cofferdam in. It was quite a size, the sheave block, as you'll see in the next coming photos, which is good. A backwall design for the jacking frame for micro tunneling, so standard stuff really within JGL. The thrust forces onto the wall is what we was looking at there. And lastly, we did a very good work with the grouting specification for the mass fill of the tunnel drive with the product pipe within. This pour was completely underwater, so there was a lot of pre-work that was done to ensure and to quality assure our work that the grout wouldn't displace when placed into the lovely warm North Sea water. These designs were all checked in-house, and we was able to offer the professional service and advice to Saipem. Obviously, there was a lot of technical queries and questions from both Premier and Saipem that we was able to sort of manage in-house and very much be a full turnkey package in terms of design and construction. Again, the designs, initial designs, again, and some of the GIs, just to show you a relative example. So on the left-hand side there, we have our 5.5 meter diameter caisson shaft. You have a tunnel slope of 0.7 degrees going down to the reception pit by others on the right-hand side there, which was a cofferdam within the sea. Most of the ground was sort of your clay, stiff clay to very stiff. Last bit there at the beach by borehole 04 to the beach, there was actually some protection measures for erosion of the cliff that was placed in there. JGL was managed to come up with a solution that we was able to miss the rocks that had been placed in there previous time to obviously stop the erosion of the cliff face. There's an overview of the tunnel drive itself. So you can see from the left-hand side there is our drive shaft within the gas terminal. You can see the 2 layers of fence there, just either side. I've got my mouse. There's the 2 internal fences there of security. Obviously, you've got your layout of the boreholes, which go all the way along to the version onto the beach. And then on the right-hand side there, you can just see what I was talking about there with the rock armor that's placed. That was obviously something that we looked at whilst we was doing our designs, and you have your nice cofferdam that was placed in there. So TBM Selection, so again, it was an all in-house within part of the JGL group. Obviously, the TBM was supplied by Iseki Microtunneling. The TBM of choice was the TCC 1450 OD, which is an Uncle Mole micro tunneling machine. The TBM was chosen due to a large amount of stiff clay within the drive geology. It wasn't a rock face machine, as the ground wasn't found to be hard enough to own. That's why we had to look at the rock armor at the end. But we made the decision that it wouldn't be any issues to the drive. One number interjack system was designed into the drive to push around halfway, just to give it the final push to the end on the over 100-meter drive length. And a part of the JGL design process, the settlement analysis was designed and checked. And obviously there was the third party with all the cliff and going into a cofferdam that was done by others. So there's a good collaboration between the whole project, between all involved, and also the external contractors that were doing the cofferdam for Saipem. There's a nice photo of it looking very clean on the way into site. It didn't look like that at the end, I can assure you, but it looks very nice in our photos. So shaft construction. So it was done by the 5 jacks there at 22 meters in depth through mostly clay, as we saw within the boreholes. It was very good ground to be digging actually for the shaft. It was no running sand or anything. It was very stiff to firm clay, so it was ideal sort of for a shaft. The main shaft was dug using the JGL's 34-ton telegrab excavator, which you'll see on the next slide. You can just see it in the top right-hand side of the photo. That was able to extend right down to the 22 meters depth, and then obviously it was bottomed out with a 5-ton excavator to get the under ream, which you'll see for the sheave block. Install of the sheave block was part of our shaft works originally. So in that time, in 2019, this was part of our works. All the shaft sinking equipment and cranes were provided by Specialist Plant and NRC, so all part of the JGL group again. So it's all encompassed within the one. We provided everything from our own. And like I said, NRC was able to retrofit the valves and spark arresters to suit on site. So that saved a lot of time and effort with going out to externals. We was able to do that within house, which is very good. So on the left here, you can, it doesn't really do it justice, I must admit. It was much larger when it was in person, I can assure you. So that was the sheave block there. This was the initial frame that the winch was going to be installed upon. And obviously on the right-hand photo there, the top plate's been taken off. So there was another plate to go on top of that, and that was cast within the slab. That was a design done by JGL in-house again in our Leeds office. So the 2 I-beams that are shown across are shown for the 550-ton pulling force that was designed to be used within the winch. Believe me, it was a very complex task lifting that in. I think we had about 20 mil either side of the shaft as it was lowered. So it was a very complex task, which obviously we was very successful in doing. Again, that was all an in-house design, so it's very sort of different from the norm anyway of putting a sheave block into one of our shafts. But it was good, complex, and obviously we worked with Saipem and Premier Royal to do this design, as it was such a importance to them. Left-hand side there, like I said, we used the telegrab excavator. That's it there digging. We did, I think, find some water within the shaft digging, but again, we was able to near enough dig the caisson dry, which is good. On the right-hand side there is the installed sheave block, or installed the plate for the sheave block that was going to be installed by others. Ace winches were there for Saipem due to install that. That's the start of our drive, looking into the tunnel itself, down to the cofferdam. The tunnel lined up exactly to the center of the sheave block, if you can picture it. And obviously that line was critical due to the winching strength that was done. I think there was about 5 or 10 mil clay within the pull due to the forces that was sort of expected when pulling from the North Sea. That's the top of the sheave block installed. That runs right the way down to the bottom, as you'll see on the other photo. So we also installed the 2 edges here for Ace winches, the 2 edges off the side of the collar there. We designed them for Saipem. So again, we was an all-encompassing package. So we was able to design all their pulling systems, and obviously Ace winches were able to install their own equipment. This is the pipe from the outside looking up. So this is the initial works that were done by Saipem there to install the pipe into the chamber within Centrica. So adjacent to us, there was another contractor working to do all the receiving parts. Obviously, we was only due down to do the shafts and the tunnel, so getting the actual pipe from the North Sea into Centrica's terminal. And obviously, this bits were completed by Saipem's specialist contractor. So some problems we found, or some sort of things we overcame. So due to the compound setup, so due to the restrictions within the compound, obviously as we saw, it was very strict on plant in and out. So it was very sort of hard to make space, and obviously our room was very limited. So we did actually use a place on the outside. So there's a little helipad that was just outside within the car park. We was able to use this as a microtunneling area and set up our system with outside. Pipes are run, we got the pipes and the slurry lines were pushed through some gates that were specially designed to have sort of a closer access to the shaft. This again was liaised with Saipem and Premier and Centrica themselves. So we're once again all working together for the common goal in completing this project successfully. JGL designed the use of the Iseki microchunneling system for the face pressures and everything. So all that was done through our design. Again, the recommendations of the machine, and obviously that went through the approval process within Saipem and Premier Oil. A full design was completed, like I said, and the full tunneling package, all the equipment and the TBM, the slurry systems, the primary and the secondaries, and all the plant was provided by Iseki and specialist partner, again, all part of the JGL group. So some construction challenges, obviously the one at the top there being COVID-19. We started our microtunneling, I remember it very well. I was sitting in my room in Hull when Boris announced that there was a lockdown. So it's very much we had to sort of work with the unknown, as it were. I think there was a lot of uncertainty at the time that people was wondering whether the world would come to a stop. We persevered, to be fair to us. We sort of had a meeting. We decided that it would be best for us to continue. Obviously, we was taking in all the measures that were given by the government at the time, for which it was very successful at the same time. Obviously, suppliers was much of an issue, but we worked with it and sort of was very upfront and honest with what we are and what we couldn't get. Another construction challenge was working with the live gas terminal. Like I said, the Coma Tier 1 site, so obviously it was very highly looked at. The MOD police were based nearby, actually opposite. They've seen them a few times, so it was a place of national interest, obviously for anything to go on there. There was obviously a large amount of damage that would be caused if the wrong person entered. So there was a lot of permits and procedures and different working conditions that we adapted to. Weather with the crane, obviously being that close to the North Sea and naturally the east side of the country being very windy, there was a few days off that we had to work with sort of cranes. So sometimes we had a smaller crane, our little 8-ton crane that was working. Obviously that could work at a much shorter boom. So obviously that was not getting affected with the wind itself. So we were sort of adapting with what we had. Like I said, the Coma site, the induction process and the pre-screening, all deliveries were checked, deliveries were booked in. There was a lot of conversations to be had, a lot of progress meetings and updates on every day just to know what was going on, obviously due to the nature of the works. During COVID, we was working 24 hours during the tunneling, so it remained a constant process. And then obviously the deliveries during COVID, once again, I think that was probably one of the main challenges. Obviously, it still poses a challenge now to the industry, but obviously the first lockdown meaning a lot of uncertainty with deliveries and a lot of sort of uncertainty what the next steps was going to be. So production review, we averaged 3 rings a shift during the shaft sinking phase. So that was the 3 rings on a 5.5 meter diameter shaft. So that's quite good going. When we was tunneling, was averaging 4 pipes per shift, so they're 2.5 meters long by 1200 ID. So again, that was good ground to be tunneling in. It was successful. Clay was found during the tunneling and processed through the primary and centrifuge on site. So the system worked very well with the ground that was expected. So everything was correct in the design. So we did very well in that sense. There was no water loss during the whole drive as well, so the water tank never actually fell empty. The water was kept through and recycled through the centrifugal system. And lastly, when we poured underwater for the last part, when the product pipe was in our tunnel, we poured 82 meters cube of specially designed grout within 2 shifts. Like I said, this went through many design phases and checks with Saipem and Premier due to their product pipe being very highly sensitive to anything. So we had to make sure that it was designed well. So production review on the grouting works. So again, there was a thorough design for the grout filling of the final product. I can tell you it was a thorough design. It went on for quite a long time, I say. The grout had to be resistive. What can I say? So the product pipe, JGL designed a specific grout that was poured underwater and provide resistance to the pipe work itself. We sat with a local supplier in Hull, but we worked with them collaboratively from the beginning, saying that this is what we was. We sort of engaged and developed with Saipem and Premier, so there was a few site visits to the plant to actually see how it was going to work. So it set a lot of people's sort of minds at rest, sort of thing. We were making sure that the product worked, and obviously there was a task-specific method statement for the grouting due to the high nature of the works. There was a very detailed, and the methodology was very detailed for all involved. That's just an idea of what was pushed. So we had almost like a floats on the 4-inch pipe being pushed down the shaft. These pipes floated to the end. It was designed with an NRV, a non-return valve on the end. That was pushed around about 100 meters down the tunnel. And then obviously we ran that pipe work up to the top of the shaft and we poured via a Camford pump. This was successful. Obviously, you can see that it's not normally normal like that to be pouring with with underwater. Obviously, this was through our design, and we found that the buoyancy on these were fantastic. So again, that was engagement from a very early stage with a local supplier, and also the suppliers of the pipework themselves to get their expertise sort of and ideas what they believed would work best. This is a snapshot of one of our designs, so it shows how in depth our design for the grouting was done. So the top left there, you've got the plan view showing the pipework and the winch that was pushing it into the shaft. That almost worked such as a sort of a catapult. Really, it was pulled back and the pipe was pushed down with sort of minimal force in the end. And obviously that goes through the stages. You can see there in the bottom left photo, you can see the red with the pipework being connected and pushed above the product pipe. You can just see laying in the invert. And then on the right hand side, you've got the water coming back up, and then obviously that's where we pour. So again, we went into a lot of detail within the design, obviously done in-house again, which obviously due to the nature, like I said, it was very key for this all to be correct. So that was the main bulk of our works, and just to sort of go into sort of JGL itself, life was a key part of within our business. So living incident free every day. It's a key nature of the business and a key nature within all of our sites. So within the project, we promote people that are working within our values. There's some lovely photos that you'll see on the next slide. So JGL worked within the life principles, as we do on every project. We had regular site meetings and workforce engagement, which was completed. So we always ask, was there a better way to do things? Obviously, some designs, there could be better ways of doing things. So we've asked the question to the site and the people that are doing it. So it's a full engagement from all. We awarded those who worked and lived our values for our best practice, as you'll see within the next slide. And obviously your observation cards were completed and acted upon. And it was a very honest culture there. We sort of understood that it was very new to a lot of people, including myself. I've never worked within a gas terminal prior. So it was getting people's ideas and sort of what was going wrong, what was going right, and ultimately making our 3 visits very successful. There's some lovely photos of me through the years. I'm a bit of a worse haircut now, I must admit, compared to them. But so obviously they're the awards we get. That's a £50 Marks and Spencer's voucher there for the operatives that are picked. And obviously you can see everyone smiling pre-COVID anyway. I can tell you all these photos were taken. So yeah, it's rewarding the workforce and obviously noticing good works and maintaining a good working culture within our team. So in conclusion there, JGL was able to complete all the specified work for Saipem. Just to go back, that was the shaft sinking, the tunnelling to the cofferdam, and obviously the final grouting and the install of the winch sheave base at the bottom. Obviously the grout was completed underwater. We maintained a strong relationship with the client, and our knowledge and experience meant we was able to overcome various issues arising in a timely and ultimately safe manner, which was the key throughout the whole project, was it being a project that was safe. Our life culture was driven throughout the project, meaning operatives were rewarded for safe working, and there was actually no incidents within the project, which is ultimately a very big positive. And the JGL group itself worked collaboratively as a full package. We was able to use all of our divisions within the JGL group to make this project a success. And there's just a phone number there if anyone else is interested. I'm sure there'll be some questions, but yeah, thank you very much for listening.
Okay, thank you very much, Cameron. A really interesting project, and it has generated one or two questions. So if you're okay, I'll start those off. The first one comes from Kieran O'Shea, and it's asking what was the size of the product pipe, and was it sat on the invert of the sleeve, or were you using spiders to hold it more in the center of the sleeve pipe?
Yeah, so basically there was a 12-inch pipe that sat on the invert, which was the main product, and then they had spiders that just sat above it. I believe it was a 6-inch pipe that sat above. So obviously when we went to actually put the tunnel, the pipe work for the grouting, it was obviously a key sort of design stage that we wasn't going to damage any of their product pipe that they put in. So hence why there was a sort of a large design process to quality assure, and obviously it went through the relevant channels. So in answer to the question, the 12-inch pipe sat up in the bottom, and then there were spiders for a pipe that sat above that product pipe itself.
Okay, thank you. So the next question comes from Kevin, and he asks, what was the maximum operating pressure of the pipeline? I guess you can answer that one quite simply, can you?
Just what the pipeline is in the gas pipeline itself, or the JGL?
I assume that's what he's asking, yes.
I will have to double check that, unless I think Kevin or Mark McGeady from JGL are on the call as well. I don't know if they know that question. Otherwise, I'll have to go and ask Saipem that question directly.
Hi, it's Mark here. No, Cameron, I'm not too sure on the exact pressure of the product pipeline.
No, I'll double check that, and I'll get back. I'll answer that question, because that'd be good to know on that product pipe. Yeah, leave that with me, that one, please.
Okay, and then the next part of Kevin's question is, what form of contract was used between JGL and the client?
So the contract with you was NEC option C, I believe, Mark.
Yeah, Cameron, that's it. Yeah.
Okay.
Yeah, it was an option C, and obviously there was a Premier Oil was the client for Saipem, so we was very much sort of in a chain there. So Saipem was the client for JGL, and then Premier Oil was the client for Saipem. So it worked in that sort of basis. There's a organogram kind of thing.
And then we've now got a question from Kazinga, who asks, was there an influence of the tide during the works?
Yeah, so obviously when there was work in the cofferdam, so mainly our cofferdam, or Saipem's cofferdam contractor, had a very limited time working, so they was tidal working. At certain times, I believe they had about 3 hours when working on the beach. Obviously we was tunneling into there during tidal time, so we had to pick our time sort of well. We were sort of getting to a point where we was at the edge of the shaft, edge of the cofferdam within the beach, and there was obviously a sort of a timing that we had to meet. So yeah, you're right, it was all tidal working for the cofferdam construction, and then also for our final piece of tunneling into the cofferdam.
Okay, right. Well, thanks, Cameron. I'll leave the questions there. There are no more at the moment. If anybody has any more questions, please post them, and we'll try and catch them at the end of the session. So thanks again for a really interesting presentation, Cameron. We'll now move on to our next presentation, and unfortunately, Kate Grant from Cadent has been able to join us, and by magic, her presentation has appeared. So I'll now introduce Kate. So our next speaker is Kate Grant. Kate is the director of the West Midlands Gas Network at Cadent Gas, and before joining Cadent, Kate worked on large infrastructure projects such as Heathrow Terminal 2 and the London 2012 Olympics. Kate has a keen interest in sustainable engineering and has previously worked on developing technologies such as electric vehicles and distributed generation. And Kate will be talking to us today about the engineering challenge of moving our gas networks towards a net zero future. So if I can pass over to you now, Kate, to deliver your presentation. Thank you.
Excellent. Thanks, Norman. And actually, what I thought I would do is just share my video quickly so you can see the ridiculous situation I'm in terms of, I think you might have mentioned that I've been having some technical issues. So the way I've managed to dial in the end is by downloading Zoom onto my personal phone and sitting in the car to get enough reception. So sorry all for being late. I'm very grateful that I'm here today. So at this point, what I might do is switch my video off because the reception's not great here, so I don't want to interrupt the presentation. Is that okay? I also just wanted to do a sound check, Norman. Can you hear me okay?
Yeah, we can hear you, and just let me know when you want me to move on your slides.
Thanks, Kate. So this is a real team effort between the two Kates. Right, so so thank you for the introduction. I thought I'd actually just describe a bit about myself because it's a large part of why I'm here presenting to yourselves today. So I actually joined Cadent just over 5 years ago, and I'm an electrical engineer by training. And when I made the decision to join a gas distribution company, a lot of my friends and peers actually laughed at me in terms of the consideration that I was going over to the dark side, especially with my sustainable background and passion. There was a big question around, well, why are you joining one of the biggest fossil fuel transportation industries that we have at the moment? But for me, there's a fundamental shift that is needed in the gas industry and gas networks to enable the UK to deliver its net zero ambitions. So where better place to be other than a distribution network to help the UK achieve these targets? So that's the basis of my conversation today, because for me, this is moving beyond a vision now and starting to become a reality. And for us as engineers, we need to start to understand what that means for us. So Kate, I'll just ask you to move on to the next slide, sorry. So the impetus for change has been there for many years actually, but it's only over the last couple of years that we've started to see a shift in political appetite for a future of gas. And I think there's still some debate about what that future of gas looks like. So it's interesting, I've just called out a few things here now in terms of this net zero by 2050, which is now in legislation. And an interesting quote related to that in terms of moving beyond the 80% target actually means that hydrogen has to be part of that future picture. It's an integral part of the strategy. And what we've seen with the Prime Minister's most recent 10-point plan and his Build Back Better and decarbonisation plan following COVID is that hydrogen continues to form part of that political rhetoric. And it's clear that the gas networks have a role to play in that. So that's really exciting that we're starting to see that political framework and that pull towards gas being a part of the future. And that's particularly important now because in 2026, the government will be reissuing their carbon budget. And it's really important that, you know, if there is a future for gas, it forms part of that announcement. What we're seeing more locally, and especially in the West Midlands, is that local authorities are actually setting their own net zero targets, and in some cases are actually challenging themselves to be more ambitious than the central government targets. So, for example, in the West Midlands, we are working with the West Midlands Combined Authority, who are targeting a 2041 net zero target. So trying to outperform the central government by 9 years, which is really quite exciting. So Kate, if I can just ask you to skip on to the next slide, please. Thank you. So what role do we have in this transition towards net zero? Now, what we have today is a significant asset and a means to distribute large volumes of high quality energy. So within the UK today, we have over 280,000 kilometers of gas distribution networks, and we transport 720 terawatt hours of energy to consumers. And what's interesting is that in the UK, population growth is predicted to double in the next 35 years compared to the last 35 years. And in this time, 9 million more people will become over 65. So what we're talking about is a incumbent infrastructure that is able to transport high volumes of energy. We're talking about a population that is only growing and therefore an increased demand for energy. And we're talking about an increase in customers who could be perceived to be in vulnerable situations. So this introduces the energy trilemma, where we are trying to move towards a low carbon future, but we do need to consider things like resilience and accessibility to energy. And to me, that's the most important thing. So accessibility is not just about the physical access, it's also about the cost barriers to achieving this net zero future. The other thing that I wanted to just mention as, in terms of our energy mix today, is that 1/3 of all UK energy consumption is for heat, which is provided by natural gas. And at peak demand, 4/5 of the demand is provided for by natural gas. So as you can see from some of these high-level figures, electrifying heat would require a significant investment and expansion of the UK's electricity infrastructure, because the gas network currently supplies 6 times more energy at peak in the coldest winters than the electricity network. Kate, if you could just move on to the next slide then, please. Thank you. So this is the point at which the high-level vision needs to be converted into a plan. So we're in a bit of a fork in the road, I think, and I think this is where we and our fellow engineers need to pick up that baton to take the vision that has been created and accepted on the political agenda, and to start converting that into reality. And this is where Cadent has started to develop these close relationships with local authorities to start to identify what those roadmaps to net zero look like. And what's really important about these roadmaps is that they are actually energy agnostic. So we're not saying we're not being leading in terms of what the solution looks like and saying that the gas is the only future. What we're doing is we're working with the electricity distribution networks in our areas to try and provide local authorities with a unbiased, rounded view of what a net zero transition program looks like for them. So currently we've completed a pathways project in Greater Manchester and Liverpool City. And only this month, the Mayor, Andy Street, announced a Pathfinder project for the West Midlands Combined Authority, and Cadent will be a key representative on that board, helping to identify what that path looks like for the West Midlands. And I'm very excited about this project, but I think that there's two things that we need to consider as part of this. So the first is that the future, that net zero journey should consider a range of renewable and low carbon energy sources. So just as an example, we currently have 7 biomethane sites connected to the West Midlands network, and we have more in the pipeline. And on a peak day, these biomethane generators can heat over 60,000 homes. So there are other elements of energy production that need to be considered in terms of this overall design. The second thing that we need to consider is its increasing variety of customers. So, for example, we currently have 9 distributed gas generators connected in the West Midlands, and we're predicting a further 19 sites in the next, a further 10 sites in the next 5 years, and these sites combined will consumes about 5% of our current demand in the West Midlands. So what we're starting to see is an energy mix that is very, very different to how the gas networks have ever operated previously. So rather than a flow of energy from top to bottom, we're looking at energy vector flows in multiple directions now, and the energy within our pipes and the calorific value of the gases that we're transporting are changing. And this is the nuance of why it starts to become important in terms of the next practical steps. So Kate, if I just move you on to the next slide, please. So some of you might already be aware of a project called High Deploy, which we have hosted in the West Midlands network in partnership with Keele University and Northern Gas. So what's really important about this trial is that it's the first time in Europe actually that we have injected hydrogen into a natural gas network up to a percentage of 20%. So our current gas safety management regulations has a limit of 0.1%. So to inject up to 20% hydrogen onto a domestic network actually required a complete review of the safety case for that network, and a very close conversation with the HSE around how we exempt ourselves from GSMR for the period of that trial. Now, this at 1:15 on the 30th of October in 2019, 100 homes and 30 university buildings started a trial on a private gas network at Keele University with hydrogen blended gas. And the actual practical trial itself followed years of preparation work. So preparation work with the health and safety labs up in Buxton, work with the appliance manufacturers such as Baxi and Bosch to understand the impact on boilers and gas stoves, and training and preparation for our operational colleagues. So for example, my emergency response engineers and my repair engineers in terms of the equipment that they would need to use, even the extent of odorization and the impact that a blended mix would have on our ability to smell gas. So all of these factors were needed to be considered as part of this trial. And this trial really kicked off the sort of practical application of what a hydrogen blend could look like and the impact that it would have on customers. So really a very important project. This project has now come to an end, and the site was decommissioned in the first week of March. but there is a next phase in the pipeline, which is to begin a trial on a public gas network now within Northern Gas on 670 homes in Winnerton Gatehead. So that's a really exciting project, but there's more work to do, because currently we've tested this concept on domestic properties. We need to test it at higher pressure tiers, and we need to test it on industrial customers as well to understand the impact it will have on them. And the final thing is we need to understand how we charge and recover costs for these changing calorific value of the gases that we'll be introducing into the grid. So that takes me on to the next slide, Kate. So future billing methodology, again, so this project, I didn't mention the Keel project. Both of these projects are funded by Ofgem through their National Innovation Competition. The future billing methodology project starts to look at the makeup and calorific value of the gas injected into our networks to understand how we can build a much more granular view of gas content to be able to charge customers for the energy content of the gas that they consume rather than the volume. So although this project was trialed on methane, the concept could be applied more globally, and the idea is around modeling the zone of influence from a gas entry point onto an existing onto an existing network to understand how we can measure the calorific value of the gas content. Just moving on to the next slide, please, Kate. So I guess I just wanted to finish off with a couple of thoughts around what are we doing today, and what are the opportunities that we have today, because currently all gas networks are undertaking an iron mains replacement program, which means that we are converting our old metallic mains into plastic pipes that can safely transport higher hydrogen content. So we have the opportunity to be very considered and focused on how and where we invest to ensure that we build local hubs of plastic networks to enable that transition to a low carbon future. In the West Midlands, we will be replacing over 1,600 kilometers of metallic pipes over the next 5 years. If you skip onto the next page, Kate, you can see there. So 2021 today in the West Midlands, we are 70% plastic. Over the next 10 years, we'll become 85% plastic. So this is where it all starts to come together for me in terms of the asset management approach we take and where we invest on our assets, and how we work collaboratively with the local authorities in those areas, and the, for example, in my case, Western Power Distribution, to identify where is our future demand, how can we between us support from our infrastructure, and therefore what is the best way for those communities to transition to a low carbon future. And on my final slide, I will end with a quote, which is one of my favorite at the moment, which is, "Change is not necessary because survival is not mandatory," which resonates for me very much within the gas industry. So on that note, Norman, I'll hand back to you.
Okay, thank you very much, Kate. Again, a really interesting presentation, and I'll just now have a look in the chat. We've got one question so far, and that is, are Cadent planning to convert mains transmission lines to plastic?
So at the moment, there's a project which I didn't mention, which is High Deploy. Sorry, not High Deploy, HyNet, which is about building a new transmission line up in the northwest, and that is about connecting industrial clusters, so connecting the sources of hydrogen generation. And I believe there are plans, if that project is successful, to look at how we expand that outwards. But at the moment, we need to understand the impact that increased hydrogen blend will have on our high pressure tier pipes bill. So I think that will be quite important to understand first. But ultimately, I do see a continued role of transmission pipelines in the net zero journey, because a key enabler of this will be hydrogen production, which naturally I think will be at sites. So, for example, Bacton or up in the northwest, and therefore that will require a transmission network to transport that gas.
Okay, right, thank you. A question from me, it revolves around consumers, and how are you going to bring them along on this journey? Because obviously, are there going to be any changes required to their equipment at home, like their boilers, etc.?
And I think that's probably one of the most important questions, Norman, because I think what we need to ensure is that the net zero journey is as less impact as possible on consumers, because the consumers as a whole is very, very difficult to shift how people behave in terms of how they consume energy. What we saw at the Kiel trial with a 20% blend is that consumers it was not necessary for them to change their appliances, and it was not necessary for them to change their behaviors. I think if we're looking at 100% hydrogen, there will be a requirement to change their appliances. But we're working with the likes of Baxi and Bosch to actually understand what that looks like in terms of their future products.
Okay, right. Okay, thanks for that, Kate. We haven't got any more questions. What I'd say to everybody, if you think of something that you'd like to ask, then please send it. Oh, hold on. Yeah, sorry, there is one more question, Kate, if that's okay. And it's, were Kiel University not interested in maintaining the hydroploy trial to minimize their emissions on their network?
Again, another really interesting question. They wanted to, so they're maintaining the technology on site to do further research. So I don't know what that research will entail, but for example, the electrolyzer is still on site. Yeah, I think the basis of the decision to continue to inject hydrogen into the network was probably largely down to the funding arrangement and the contractual arrangement of the innovation project.
Right. Okay. And then we've got, and I don't know, it says from Jay Brown has asked, is it crucial that the pipes are all changed to plastic in order to be able to carry hydrogen?
Another unknown. So I think the no regrets is that plastic is a better carrier for hydrogen, but I do know that there's research underway to understand the impact, for example, the leakage behavior from metallic pipes. I've not seen the outcome of that research yet. The only thing that I do know is that hydrogen does have an impact on steel. It makes it more brittle, but that's the only thing I know.
Right. Okay. So I think that concludes the questions now. If, as I said earlier, if anybody does have any further questions, if you send them into Guild HQ, and we'll pass them on to the to the presenters, and I'm sure they'll provide an answer. So to conclude, I think we've It's been really good for me to see so many members joining our webinar today, and I hope you'll all agree with me that we've had two really good presentations. And I'd like to thank Cameron and Kate for taking the time out of their busy schedules to provide us with such thought-provoking and interesting presentations today. As I said at the beginning, we do have a packed program of events for April, and the highlights of these are on the 6th of April, Stanley Black & Decker, who have got a webinar on tool solutions for safe pipeline construction. Then on the 8th, we have Anglian Water with the new self-lay code for water mains. And then on the 27th, the Eastern branch are hosting a webinar on the development of a certification scheme for plastic pipe weld inspectors. And then finally, I'd like to again just remind you that we are seeking submissions for this year's Guild Awards, and for the Midland branch, Sir John Parker, and the Scottish branch, Karen Trophy PDN competitions. So please get your entries in as soon as possible. And for further details on all these events and our future programme, then please visit our website, pipeguild.com, or look out for our posts on email or social media. I'd finally like to thank you all for attending and supporting the Guild, and we do value your feedback on all our events, whether it's good or bad. And in addition, please let us know what you'd like us to cover within our programme going forward. We're always happy to speak to our members, so please don't hesitate to contact us at HQ. So thank you again for attending today, and I hope you have an enjoyable rest of today and have a really good Easter holiday. Thank you, and goodbye to everyone.